Okay, so this is practice test 4. There are 29 questions. I'm going to do non-repeated question only. Number 1, plot the graph of this parabola. First of all, find the vertex. Vertex is 3 comma 4. So, and then I need at least 1 point. So I'm going to choose a point, let's say x equal to 2. So this is the function f of x equal x minus 3 whole square plus 4. Vertex is coming from this 3 comma 4. I'm going to find out the value of the function when x equal to 2, because at least I need 1 point to plot the graph of parabola. When you put x equal to 2 here and do the simplification, that will be 5. So at 2 the value of the function is 5. So I'm going to plot these 2 points. The first one is x3 4. Second one is it's facing up, so click somewhere, and then the point is at 2 5. You see, when x is 2 the y is 5. So now that's a parabola, but we also have to plot axis of symmetry, which is a line passing through this vertex, vertical line, but we need to use the dashes line for this one. So that's the graph of the parabola with the axis of symmetry. That's perfect. Let's go to the next step. Next step is vertex. We already know it's a 3 comma, what is that, 3 comma 4, and the axis of symmetry is x equal, always it's x equal the x coordinate here of the vertex, which is 3, and then the domain in the interval notation, as you can see here, the graph, the domain is any real number from left side to the right side. So you can just use parentheses from negative infinity to positive infinity. And finally the range is the y value. It is start as the vertex because it's concave up. So from 4, you see here the y value is 4, it's going up, and there is no boundary for the up value. So it's 4 from 4 to infinity. So close bracket for the 4 because 4 is included, and then open bracket for the infinity. So that's the question number 1. Question number 2, we have given quadratic function. We would like to write down this quadratic function as a standard notation like this, and then we can answer all this question like problem number 1. Okay, so how do you go from here to there? You have to complete the square thing. So I'm going to show you how to do it. Question number 2. So you have n of x equal x squared plus 4x. Write down this 3 somewhere far, a little bit far. We have to complete this square by adding square of half of this number, which is 2 squared. But you cannot just add some number randomly, so you also have to make it balanced by subtracting the very same number. By doing that, for first 3 numbers, first 3 terms, you can write down x plus 2 whole square. That's called completing the square. Okay, either you write x squared plus 4x plus 2 square, or you write x plus 2 whole square. That's the same thing. You do the calculation here, which is 3 minus 4, so it's eventually be -1. So now if you compare this one with the standard equation of the parabola, there is nothing here. That means a is 1, h is, because here sign is plus, you have to make it minus, so h is -2 and k is -1. And now from that we can answer this question. Vertex is -2, -1, because h and k is -2 for the h and -1 for the k. And now we can answer all these questions. Okay, so the vertex form of the function is, it's x plus 2 whole square minus 1. It's x Okay, it's x plus 2 whole square x plus 2 whole square minus 1. The vertex is -2, -1. X-intercept means what happens if this function is 0. That's the x-intercept. So meaning if you equate this function nx equals 0 and solve for x, that will help you to find x-intercept. So you can use factoring or what is that, quadratic formula. So 2 plus 1 is 3, so that means x plus 2 x plus 1. Is that the case? No, it's a 3 minus 3 plus 1 is 3 plus 1 is 3, 3 times 1 is 3, 3 plus 1 is 4, and 3 times 1 is 3. So these are the two factors. So if you solve it, they will give you x equal -3 and -1. So these are the two x-intercepts. So x-intercepts are, use the order pair. So you have to write down this -3, comma 0. That's how we write down the x-intercept, because the y value for the x-intercept would be 0. -3 and -1 are the two x-intercept. The y-intercept means, look at here, just put x equal to 0 in the given function, it will be 3. So the y-intercept is, in the order pair, when x is 0, the y is 3. And then graph, it's easy to plot. We can plot the vertex, which is -2, -1. We can plot the x-intercept, which is -3, 0, -1, 0. We can plot the y-intercept at 0, the value of y is 3. So with all this information, now we can just click here, put the vertex, which is -2, -1, and then select one of these points. That will be our parabola. What is the axis of symmetry? It's the x coordinate, which is -2, x equal -2. That's our axis of symmetry. Always the minimum value comes from the vertex. As you can see here, it's giving you the minimum value. The function n has minimum value because it's facing up, and the minimum value is the y coordinate of the vertex, which is -1. Always keep in mind, the parabola gives you either maximum value or minimum value. The interval, the domain for the parabola is always all real number, and range comes from, if it's a concave up, starts from the vertex, go up to infinity. So that means it's starts from -1, goes up to infinity. Okay, so that's question number 2. Question number 3, one more time. This is graphing parabola. It's exactly like question number 2, so I'm going to skip it. Plot 5 points on the parabola. This time you have to plot 5 points. You can find the 5 points like we did in problem number 2. You can find the x-intercepts, you can find the y-intercept, you can find the vertex, you can find some other points as well. Okay, I'm going to skip it. Number 4, the graph of quadratic function with the vertex 3, 0 is given here. The range is it's always start from the minimum value, goes up to infinity if it's concave up. In this case, it's concave up, so use close bracket on the left, starts at 0. You see the y value is 0 and it's going up to infinity. The domain is, it's all real number, because domain means it's x coordinate, x values. It's going from -infinity to +infinity, so it's -infinity to +infinity. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116 graph the parabola one more time. You can plot the graph, it's not big deal, but follow the instruction here. You need 5 points. Remember, this parabola has a negative, leading coefficient, so that means it's going to be facing down. Okay, find the 5 points, plot it, and facing down. Remember, when you try to use the 5 points, you have to take 2 points to the left of the vertex and 2 points to the right of the vertex. Okay, so I can do this. Let's say number 5. There are two ways you can find the vertex. Either you can use the formula for the vertex, which is, if you have quadratic function like this, if a is negative, then the graph would be look like this, and vertex can be found where the x coordinate of the vertex can be found by using this formula, negative b over 2a. In this case, b is -8, 2 times a is -2. So if you divide 8 by 4, it's going to give you 2. So that's the x coordinate of the vertex. For finding the y coordinate, which is k, it's actually the value of the function, this function at h. The value of the function at, in this case, it's a 2. So go here and replace x by 2. So -2 times 2 is squared, -8 times 2, -11, and if you just simplify this, it's 8 minus 16 minus 11, and eventually it's okay, I did a little bit mistake here. When I do this calculation, negative times negative is positive, and because of this negative, eventually it will be negative, so it will be -2. Okay, so if you plug -2 now, if you just replace x by -2, this calculation will be a little bit different. So the first case it's -8, but the second one it would be negative times negative is positive 16. So now, as you can see here, 16 minus 8 minus 11, it's eventually -3. So the vertex is -2 comma -3. So that's the vertex. And now, after finding the vertex, we need 2 points to the left. So we have to pick something. Let's say x is -2. So find the value when x is -1. Find the value of the function when x is negative to the left. So that means find the value when x is -3, -4. To the right, you can choose -1, 0, because these are the right points. But you need to find the value of y coordinate for this x coordinate. So I'm going to do that here. If x coordinate is -3, the y coordinate would be plug the value of x -3 here and do the calculation. That will be -2 times -3 whole square, -8 times -3, -11. And if you do this calculation on your calculator, it will be 9, -18, positive 24 minus 11. So that is eventually negative 29, and then so -5. Okay, when x is -3, the y is -5. Okay, when x is -4, the y would be, do this calculation, use your calculator, it would be 32, so that would be -11. When x is -1, put that value here, it would be -2, positive 8, -11, so it's -5. When x is 0, the y is -11. So these are the value I can put. Okay, so these are the points. At -3, the y is -5. At -4, the y is -11. At -1, the value of y is -1. At 0, it's -11. So I'm going to plot this value here with the vertex, which is -2, -3. So click here -2, -3, plot it. -3. At -3, the value is -5. -5. At -1, the value is -5. At -4, the value is -11. And at 0, the value is -11. So plot it. After that, just choose the graph, click it here, facing down, everything down. Okay, so that's number 5. So number 6, answer the following question. This is quadratic function. As you can see here, the value of a, which is leading coefficient, is negative. Negative means facing down. Facing down means you are going to find the maximum value. Where does the minimum or maximum value occurs? In this case, remember, the maximum or minimum value occurs at the vertex. So you need to find the vertex. So vertex can be found by using the same formula, negative b over 2a. When x is negative b over 2a, in this case, b is -4, a is -2, and if you divide 4 by 4 and there is a negative sign, that will give you -1. So when x is -1, that's where you are going to get the maximum value. And what is the maximum value? That's the y coordinate. So when x is -1, what happens to the value of the function? That is maximum value. So I'm going to plug x equal -1 here and do this calculation, which is -2, +4, and eventually that's +2. So that's the maximum value. The maximum value is the y coordinate, +2. Check it. That's question number 6. An aircraft factory manufactures an airplane engines. The unit cost, so this is the unit cost function, is in dollar, and then depends on the number of engine made. If x engines are made, so x represents the number of engines and c of x represents the cost function. How many engine must be made to minimize the unit cost? So for this, if you see here, this is cost function, which is parabola, and then coefficient of x squared is positive. So this is the parabola you're going to get, and to find the number of engine, which gives you the minimum cost, you need to find the vertex x comma c of x. If they ask you number of engines, that's the x. If they ask you the minimum cost, you need to find the value of c of x. Okay, sometimes they ask you x, sometimes they ask you the y means the value of function. So in this case, to find the x, there is a formula for finding the x coordinate of the vertex, -b over 2a. In this case, b itself is -594. 2 times a is 0.9. So if you divide 594 negative 594 divided by 2 times a, which is 0.9, that would be 330. So the number of your plane, how many engine must be made? So 330 engine must be made to have a minimum cost function. Number 8, this is the composition. For finding this composition, first of all, you have to know h composite f -1 means h at f when x is -1. So first of all, find the value of f at -1 by using this function. Just replace x by -1 and then do the simplification. That will be -6, which is eventually 5. So now, after finding f of -1, just plug this value here and find, sorry, it's not negative, it's +5. Find h function at 5. So h is this. At 5 means 8 times 5. Replace this x by 5. So that would be 8 times 5 plus 1, which is 8 times 5 is 40. It's a 41. So the answer for this one is 41. Okay. Find the composition like before. You can find the composition, but instead of at some specific number, there is a x, so you need to find p composite n of x, which means the value of p at n of x. So look at the function p here, and wherever you see x, replace that x by some box. So box square plus 9 times box. Instead of box, we need to put the value of n of x. N of x is x plus 7. So we are going to replace this box by x plus 7. But remember, there is a square for the box, so you need to find the square of x plus 7, which is eventually x squared plus 14x plus 49. If you multiply x plus 7 times x plus 7, that is what you are going to get. And you have to multiply x plus 7 by 9. That's going to give us 9x plus 9 times 7 is 63. So just simplify this. It is x squared plus 14 plus 9 is 23x plus this one is 112. Right? So that's our answer. X squared plus 23x, x squared plus 23x plus 112. So x squared plus 23x plus 112. Okay, so the domain of p composite of nx is, for finding the domain of this composition function, first of all find the domain of n of x, which is all real number, and then from that if you see any restriction in the composition function itself, then remove that restriction from the domain of n of x. But as you can see here, the composition function is just a parabola, so there is no restriction. And then the domain of n of x is also all the real numbers, so eventually it would be all the real numbers. So from negative infinity to positive infinity, there are some steps you need to follow for finding the domain of composition function. Number 9, find the composition one more time, and then you find the domain in interval notation. I'm going to skip this question because it's very similar to problem number 9. Find the composition and look at the okay, here's the thing. I can do this problem because the domain and the function has a restriction here. So first of all, let's find the function m composite of nx. So here the inner function is n and outer function is m. So go to the m function, replace that x inside the m function by box, and inside that box plug the value of n of x, which is x plus 4. So eventually that would be x plus 7. So that's the composition final function. But before finding the domain of this function, you need to look at the domain of inner function n of x. So what is the domain of inner function n of x? It's all real number. And then what is the domain of this restriction here? The domain of the restriction is x plus 7 inside this radical sign has to be greater or equal to 0. So if you solve this, it has to be greater or equal to negative 7. So the answer for the domain is greater or equal to negative 7, and they are asking us to give in the interval notation. Is that write a number in the interval notation? So this one is square root of x plus 7, and then domain is in the interval notation greater than, what is that, negative 7, and goes to positive infinity. Okay, that's problem number 10. Question number 11, for each function graphed, we have given graph of function. We need to find out either they are 1, 2 or not. So one thing you have to keep in mind to check either given function, given graph is 1, 2 or not, you have to apply the horizontal line test. If you see any horizontal line intersect that graph more than once, that means that's not 1 to 1. For example, first one you can see here, there are so many points. You can see what I'm trying to say is, first graph, this is the graph, there are so many horizontal lines you can see which will be intersect this graph at more than one point. So this is no. Here you can see once again the very same story, even the x-axis is intersecting more than once. This one, no horizontal line is going to intersect at more than once. So this is yes. Remember, this is open circle means no point. Solid means it's a yes point. Oh, sorry. If you draw a horizontal line here, even the x-axis, it's intersecting at more than one point. So it's also no. I'm sorry about that. Okay. Even the x-axis is intersecting here and then here. So it's no. For graph 4, no horizontal line is intersecting more than one point. So the answer is yes. S means it's a one-to-one function. Same number 5, same number 6. So these are the answer for this question. Let's go to next problem. Find inverse, check either these two functions are inverse of each other or not. And this is how you can check. If two functions are inverse, then composition of these two functions supposed to give you, from both sides, supposed to give you x as your output. So we are going to find out f composite of z first, which is finding the value of f at g of x. So meaning, go to the function f here. For wherever you see x, just replace that x by some box, and in that box plug the value of g of x. That's the meaning of finding f at g of x. So g of x, we can see here, it's x plus 1 over 4. So now open that box and do the simplification. So this 4 and this 4 is gone, and then x plus 1 minus 1, which is x. That's what we were expecting. So the first test is okay, that passes the first test. We have to do the same thing for the second one. So z composite f of x means finding the value of z at f of x. Go to the function z here, copy that, but at x, just replace that x by box, and in that box plug the value of f of x, which is 4x minus 1. So if you open that box and do the calculation, it's going to give you 4x over 4, and eventually that's going to be x. So since both of these requirements, they are true, so these two functions are inverse of each other. Okay, now find the inverse of this function g of x. You can do that by following some steps. So the first step is write down this function as a y, and replace this y by x, and replace this x by y, and now solve for y. To solve for y, meaning everything else goes to one side, the y goes to other side. So here is the 3. So first of all, multiply both sides by 3. By doing that, you are going to get 6 minus y. You also have to bring this 6 on the other side. So subtract 6. So that will be 3x minus 6 equal negative y. We don't need negative y, we need positive y. So just multiply both sides by negative 1. By doing that, this negative becomes positive. So y equal negative 3x, negative 6. So this y finally represents the inverse of the given function. So inverse of g of x is negative 3x and negative 6 if you want to use the parentheses. Otherwise, you can just open the parentheses and eventually it's going to be negative 3x, positive 6. So it's a negative 3x and positive 6. Okay, find the inverse. This is exactly the same thing we did before in problem number 13. So I'm going to skip it. I'm going to go to question number 15. Exactly the same way. Write down the function as y and then replace x and y, and then isolate y. And that is going to be your inverse function. So go to number 16. One more time, this is about the inverse function, but it's a little bit different than previous problem. So let's talk about this. We have given one-to-one function f. The domain of this function f is negative 1 to positive infinity. So that means the function f is going from negative 1 to positive infinity. That's the domain. Going from here to the range 4 to infinity. So that's the range. Now inverse means going back. So when you go back, this range of the function f becomes the domain of f inverse. So that's the reason the domain of the f inverse is this 4 comma positive infinity. It's just a reverse of the original function. And then range is the domain of the original function, which is -1 comma positive infinity. That's all. Let's go to next problem. Question number 17. When you try to plot the graph of inverse function, you just have to switch x and y coordinate. And for a graph like this graph is combination of 3 different lines, 1, 2, and 3. So you just have to switch. You just have to plot these critical points, 1, 2, 3, 4 points. So the inverse of this point, which is 8 comma 7, is 7 comma 8. So I'm going to plot 7 comma 8. Do you see that? So inverse of this 8 comma 7, if you switch x and y coordinate, that becomes 7 comma 8. So now go to this point, which is 7 comma 3, that becomes 3 comma 7. Now go to this point, which is positive 2 comma -3, that becomes -3 comma positive 2. You just have to switch x and y coordinate of these 4 points. Finally, this point is -2 comma -4, that becomes -4 comma -2. Now the thing is, after plotting all these 4 points, you just have to join them by using straight line. Okay, that's all. So that's the graph of inverse of this function. Find the, plot the graph for exponential function. So as you can see here, plot 5 points on the graph of the function. So for finding the 5 points, you can always, find the table for the points first. So this is choose x and find the value of f of x by using this formula, which is -5/8 to the power -x. So I'm going to choose x equal 0 because that's easy to choose. When I replace this x by 0, this expression becomes 1. So that is going to give me -1. So at 0, the value of this function is -1. I'm going to choose, because it's negative, I'm going to choose some negative value. Let's say -1 for x. So if I replace this x by -1, that negative and this negative already here becomes +1. So eventually this value of the function becomes -5/8, which is at -1, the value of the function is -5/8. If I choose x equal 1, then this becomes -1. -1 means you just have to flip this. 5/8 to the power -1 becomes 8/5. So eventually the value would be -8/5. So at +1, the value would be -8/5. We need 2 more points. So if I choose, let's say 2, here 2, so that becomes -5/8 to the power -2. So -5/8 to the power -2. You can plot, you can just simplify this. This negative makes this reverse, just reverse it, and that becomes +2. And then 8 squared is 64, 5 squared is 25. So that gives you -64/25. So let's do very last one for the -2. Since there is a negative and this negative becomes +2. So eventually that would be 25/64, because 5 squared is 24 and then 8 squared is 64. So I'm going to plot these values. You can see here at 0, the value is -1. Plot it. At 1, the value is -8/5. If you don't remember that, at 1, the value is -8/5. At -1, it's just a flip of that value. It would be -5/8. At positive 2, the value would be negative, let's double check, positive 2, it's negative 64 over 25. 64 over 25. And at positive 2, the value, okay, I put for the positive 2, so I'm going to put for the negative 2, the value would be, at negative 2, it would be negative 25 over 64. Negative 25 over 64. You just have to plus these 5 points, plot 5 points on the graph of the function, and also draw the asymptote. So remember, this is your exponential function. For the exponential function like this, b to the power x, the graph is look like this, and this line, this line is your asymptote. But if you try to plot the graph for negative of that, this graph becomes like this, but asymptote would be still same. So the value of b in this case is 5 over 8. 5 over 8 is less than 1, so it would be the type of the graph would be actually look like this, but the asymptote is still the x-axis. And then when you try to plot the minus of it, that's going to be like this. Okay, so choose this one, that's the, okay, choose the asymptotes. It's not vertical asymptotes, it's horizontal asymptote. Where is that? This is the one. Put it here and then choose the graph and check it. Great. Question number 19, it's the same as the previous problem, but here is one more thing you have to do. You have to start with the graph of 2 to the power x, which is actually this one, and there is a vertical asymptote, this one, but you have to do the transformation this time. From 2 to the power x, you have to go to the 2 to the power x plus 1, which is horizontal shift to the left 1 unit. This graph, take this graph, shift it 1 unit to the left, and minus 4, shift that graph 4 unit down. So its translation is 1 unit left, this point goes here, and 4 unit down. Yes, so this point 0, 1 becomes negative 1, negative 3. Yeah, okay, it's a horizontal shift to the left and vertical shift down. Okay, find the range and domain. As you can see here, the domain is everything. No, domain is from negative infinity to positive infinity if you want to use interval notation. But if you don't want to use the interval notation, here they are saying write your answer as inequality, as x or y. So first they are asking you what's the range. Range means the y value. The y value is starting from negative 3 but not including negative 3. So y is greater than negative 3. Negative 3. Sorry, that's the range. Y is greater than negative 3. And then x is all real number because it's going from negative infinity to positive infinity. You see that? For whenever you start from negative infinity and then there is an arrow, that means it's keep going. So the domain is all real number. And that's the case for exponential function. For the exponential function, domain is all real number. This is the graph of exponential function like the way we did for problem number 19. It's exactly the same thing, but one has just a horizontal shift to the left. Okay, find the domain. Domain is all real number. Find the range. The range, it's above the asymptote. So you can find, you know the asymptote is y equal to 0. So the range would be from 0 to infinity. Plotting the graph, it's the same graph but shifted 3 units to the left. Okay, so the domain is all real numbers, which is from negative infinity to positive infinity. Range is from, what is that? From 0 to positive infinity, not including 0 because y equals 0 is your asymptote. And finally the graph is this is your horizontal asymptote, and plot some points. Plot 2 points on the graph of the function. So 2 points would be at 0. If you put x equal to 0 here, the value would be 3 to the power 3, which is what is that? It would be 3 times 3 times 3, which is 27. So we don't have the boundary, the space for the 27, so we need something else. So let's start from negative 3. Instead of at 0, at negative 3, the value of the function would be 1. You remember that 0, 1 point just shift to negative 3, 1. And now pick negative 2. If you pick the negative 2, that will be 3 to the power negative 2 plus 3, which is 3. And pick, negative 1, that will be 3 to the power negative 1 plus 3, which is be 9. Do you have 9 here? Now at negative 1, here is the 9. Yeah, that's point available. So just click it here, click on these points, then that's enough. Okay, I'm not going to repeat the very same thing. This is exponential function, and use some translation, and then you are going to find the answer for this. 23, use a calculator. So where is the calculator? Here, this one, and then find out this value. It's easy peasy. So e to the power 0.1 equal 1.105, but it's saying do not round any intermediate. Round your answer to the nearest 1000. 1000 means after decimal there should be 3 digits, 1, 0 and 5. So it's a 1.10 and 5. The next one is 350 times e to the power negative 0.75. Enter. It's 165.328. Remember, after 8 there is a 2, which is less than less than 5. That's why it stays 8. Okay, go to number 24. Solve this exponential equation. So remember, one thing you have to know, if there is a equation like this with the same base on both sides, then the exponent, this would be equal. So in this case, if you can convert this 27 as a base of something, and then 81 as a base of very same base, then we can solve that problem by using this relation. So we know 27 is actually 3 to the power 3. 81 is actually 3 to the power 4. So we can convert this problem as 3 to the power 3 to the power negative x minus 5 and 3 to the power 4. So the meaning, because they have the same base 3 and 3, the rest of the thing, like 3 times negative x minus 5 equal 4, this would be equal. So now just solve this one. So this is negative 3x negative 15 equal 4. Add 15, that is negative 3x equal 19. So just divide both sides by negative 3. That's going to give you x equal negative 19 over 3. So the answer for this one is negative 19 over 3. Okay. Great. Let's go to the next problem here. Problem number 25. Exactly the same thing. 3 to the power 3c minus 6. This 1 over 9 can be written as 9 to the power 1. What I'm trying to say is this 1 over 9 is actually 9 to the power negative 1. And 9 is actually 3 to the power 2. So this 1 over 9 is actually 3 to the power negative 2. So we can change this problem as a 3 to the power 3c minus 6. And on the right side, it's a 3 to the power negative 2c plus 3. Now just equate these two values here and solve for c. I'm going to skip this. Exactly the same thing. Bring this e to the power 3 on the top, change the position, and that will be e to the power negative 3. And solve this equation. E to the power 2x plus 3 equal e to the power negative 3. So this is actually 2x plus 3 equal negative 3. And now if you try to solve this equation, then just subtract 3 and then divide it by 2. So x would be negative 3. So when you type your answer is a set, so you just have to put x equal negative 3 here. Okay. This is an application problem for exponential, exponential function. You have to know formula for this. Here, read the question. Dan borrowed $8,000 at rate of 7.5% compounded annually. So you have to know that compound formula. So this is the formula I'm talking about. A equal P times 1 plus R over N to the power N times T, where P stands for the principal, R stands for the rate, N is number of times compounded annually, and T is number of years. So in this case, principal is 8,000, so P is 8,000. Rate is 7.5%, which is, you have to write it down in this form, 0.075. Compounded annually means N equal 1. Assuming he makes no payment, how much will he owe after 6 years? So time is 6. So you plug this value back here using a calculator. So we have a calculator available. So it's 8,000 times 1 plus R is 0.075 divided by N, which is 1. So eventually to the power N times T. N is 1, so T is 6, so N times T would be 6. If you hit enter, that's the amount he owes. What's the question? How much will he owe? So that means it's if you round it to the nearest cents, it would be 12,346 dollar 41 cents. An initial amount of 2,100 is invested in an account at an interest rate compounded continuously. So here, instead of using compound n times a year, we need to use compounded continuously, which is A equal P times e to the power R times T. The initial amount P is given, rate is given, and then time is 7 years. You just have to use this formula. So it's a 2,100 e to the power 0.05. Time is, what is the time? 7. Just type this thing using this calculator here. 2,100 times e to the power 0.05 times 7. Enter it. It's a 2,980 point, how many cents? 1 cent? 0 cents. Nearest cents, so it's a 0.04. So 2,980. Yeah, if you round it to the nearest cents, that should be rounded to your answer. Okay, be careful. 0.0. Your answer is incorrect. What did I do wrong here? So let me go back and check. What is that? This one. I just typed 2,100 times e to the power 0.05, sorry, what's that, 2100 e to the power 0.05 times compounded continuously 7 years, 7, yes, equal, it's a 2980.04. I did not put 4 here, so that's the answer. It's a 4 cents. So I forgot to round it to the nearest cents, or not forgot, but I did it wrong. So finally, question number 29. How much should be invested now at an interest rate of 6% per year compounded continuously? Very same formula, but instead of finding A, you're finding P. So the formula is A equal P times e to the power r times t. So to find the P, you just divide both sides by r times t, e to the power r times t. So that will help us finding the initial value P. So how much you want to make? That's A, which is 1500. E, what is the rate? It's 0.06 times how many years? 5 years. So type this expression here using the calculator. 1500 divided by e to the power 0.06 times 5. That will give you the number rounded to the nearest cents, $1,111.23. Don't forget that, because after this 2 there is a 7, so you have to round it, this 2 to the next number, which is 23. So it's 1111.23. That's all.